Can you see my screen?
Yeah, yes.
Good. So today we will talk about JavaScript. So until now we were talking about the layouts, about the uh, about some visual sort of things, about how our interactive elements look when we interact with the web page. So it was mostly about the user interface and about how our websites look. Today we will start talking about JavaScript, and this is more of what the programming exactly is. So unlike HTML and CSS, which are responsible for how websites look, JavaScript takes care of how they function and how those interactive elements work. So for example, if the user clicks on a button and there is some functionality hidden under the hood, and when we write scripts for these buttons, we create this functionality, and JavaScript is the tool that will that can help us to do this. So the agenda for today is the following. First, we will um, uh, talk about the ECMA, the current standard of JavaScript, and the organization which is responsible for creating new JavaScript standards. We will talk about the structure of the JavaScript code, about data types, and some operators, loops, variables, functions, and all other tools that JavaScript consists of, and that help us create functionality to our websites. So ECMA 262, what exactly is it? There are different definitions of ECMAScript and JavaScript. So sometimes you can confuse these two definitions, and let's define what they are. So ECMAScript is an object-oriented programming language for performing computations and manipulating computational objects within a host environment. So here's the definition that is given by the ECMA organization. So this is an international organization that creates these types of languages. And JavaScript in particular is a programming language. So it is like a particular case of ECMAScript, and it is a programming language that can help you create dynamically updating content, control multimedia, animate images, and so on. So ECMAScript is in general the type of such language, and JavaScript is a particular case. So it is an exact programming language. And we can also say that it has different approaches or different paradigms that can be used when we work with the language. So these approaches are the following. It can be imperative or declarative, and it can also be object-oriented or functional. So these are different approaches. I could also say that they are opposite to each other. So as you may know, sometimes there are people who are in favor of object-oriented approach, and there are also people who prefer functional code. It depends on what is how to say, what units, what tools they prefer while they write the JavaScript code. And JavaScript is this type of language that contains both, that can provide both approaches. It can be both object-oriented and functional. In ES 2015, which is the standard that was created in 2015, it can also the new functionality was provided, so it can help us write asynchronous code. What it exactly is, or we will talk about it on later classes. So it helps us work with big amounts of data. Here you can see different paradigms that we use within this language, and the examples of how they are implemented. Don't worry if you don't understand any code that is written here, but if you have already worked with JavaScript, then probably you can see some familiar words. So for example, we have functions for functional programming. We have objects, and we can also make our code do something, which is the imperative approach, and the declarative approach is that we define different functions that we can work with. So here you can see the development of JavaScript, and we can see that functional programming is developing faster than any other approaches. So I don't want to talk much about history today, because you can easily Google this information, and it's not very useful for our lecture because we have too many slides for today. But as I have already said, that JavaScript equals to ECMAScript. So JavaScript is ECMAScript, and ECMAScript can be either JavaScript or any other language that fits the definition. It was invented by Brendan Eich at Netscape, and it was then developed. So it exists since 1997. The standards are described as ECMAScript. So you will probably see these names as ES15 or ES5 or ES6, and it declares the current standard that we use. So here you can see the history, different standards, and how they appeared. So the first standard was invented in June 1997. These standards up until the ECMAScript 5, they are not currently used. So ECMAScript 5 was something that was widely used. So even today, if you work on some legacy projects, you can meet the ES5 standard. And the ES6 standard, it was a very, very large update, and it was, I would say, it completely changed the language and even the syntax. A lot of new features were added. So mostly if you talk about standards, today there's a big difference between ES5 and ES6, and everything else that was added later than ES6, it's sometimes it is united with ES6. So the main division lays here between ES5 and ES6. There is also this TC39 committee that evolves JavaScript, and there are yearly releases. But as I said, this standardization is an ongoing process. So currently, there are not so many features that are added, and they are added continuously, gradually. So you can even miss them. So it's not this huge event as it was in 2015. Some features are added, but mostly if the language changes, most features are changed to make the syntax more, to say easy, to make the syntax easier to use. So, for example, if this writing existed in older standards, currently this syntax is more common. Don't just try to understand what's going on here, but this this line, it just shows you how these changes are made. If you have questions of what editor you should use to write JavaScript code, here are some advices. So you will need the terminal. You probably, if you work on a production project, you will use linters that are implemented into the project. You will probably use Git, and you need your code to be highlighted as well as it was if you used the HTML. So basically, all editors that you probably have been using till now, they suit they're suitable for working with JavaScript. So it can be Atom, it can be WebStorm, or it can be Visual Studio Code. They all fit our goals. VS Code and WebStorm are probably the most popular. The first one is free and the second one is paid, but probably if you work on a team and all the members of the team are using the same editor, probably it will be easier for you to use one as well. Well, for example, personally, I use VS Code. I don't know, just I'm just used to it. And among other tools, you will also need the developer console. If you worked with the code inspector, you probably already opened the developer tools, and if you were creating layouts, you worked mostly with the elements tab, but you can also switch to the console tab, and here if you log anything, if you create different logs or something like that, then you can see all your logs here. I can make it bigger. So for example, I can write my code even here. For example, for, I don't know, some variable equals 5. And I can write console log variable, press enter, and I see 5 here. So I can interact with this interface as a developer. So you can, when you work with JavaScript code and you want to look at some side effects that you are creating, for example, you have a variable which is a result of some operations, and you want to look at the value that this variable has in this exact moment of time, you can write a console log and you will see the output here. But if you work with the Git environment and you have to merge your code with the project, you should always delete these things that you have written. Because sometimes even the linter programs would not allow you push this into your production code. Sometimes you can also use alerts to see the value. For example, here we can write alert 1, 2, 3, and here we see an alert, a model window that says 1, 2, 3. So this is another option of how you can see the output. But console log is probably the most common. Okay, so if we talk about how we can start writing our JavaScript code, there are different ways of how we can do this. So let me open another JSBin window. So here we have our HTML file. Let me hide the CSS here. Okay, so we can do the following. We can either write our script within the HTML file. So for example, let me do this. I have a div class of my class and text of my text. And after that, I can open a script tag. It has an opening and a closing tag. Script. And I can do, for example, the following variable element. Let me just run this. Sorry, text content. Yeah. So here is what it looks like. So this console is pretty much the same that we can see here. Just more, just an easier environment. So what did I just do? So I created a div and I created a small script which claims create a variable which will have a value of document with an element with class of my class, and log what is inside this element. This one is an inner function of inner method of JavaScript, so you can just you can with the help of text content, you can log any content of any element. So here is what we see in our console. So this is how we create one of the ways of how we create scripts. We can also create a separate file with the .js type, and we can, for example, let's imagine that that is written in a separate file, and here we write a script with the source attribute. Let's imagine that it is placed in the same folder. So for example, script.js. This will work exactly in the same way. The only important thing that you have to remember is that, for example, if we write, so for example, if we put it like this, so we can write as many scripts as we want. So for example, this code and this code will both work. So first, this script will work, then our browser will go to this file, and everything that is written inside the script.js will be will work as well. However, if we try to do this on this tag and write something inside, this syntax won't work. So don't ever do this. So instead, it's better to create two scripts. And there are also different attributes such as async and defer that we can use if we want to work with our scripts. So let's imagine if we write our scripts and our HTML code like this, everything goes fine. However, our script, if it works with different elements that are here on a page, it needs to wait until all of these elements are loaded. So, for example, if we move our script here and it uses this element, it won't work. So won't work. I'm sorry. Just trying to read this comment. Yeah, so this script won't work, or it will work with errors, because if it tries to work with this element still does not exist on a page, and the script will try to address it, and it doesn't exist, and it will create an error. This way of writing is okay because it waits until all the content on the page is loaded, and then it works with these elements. It is okay, but it is kind of slow because it has to wait until the page is loaded, and only then it loads the script, and after that it executes the script. So it can be kind of slow. What we can use here, we can use our async and defer attributes. The defer attribute, if we put it like this, we can place our script anywhere we want, so even here. What will it do? It will wait until the page is loaded, and after that, it will execute the script. So the script and the page are loaded at the same time. And after everything is loaded, it will be executed. So this one is slightly more effective than the previous one, than putting the script at the end of the page. And async attribute like this, it will be executed as soon as the script is loaded. So it starts loading when this line of code is read by the browser, and it starts loading, and then it starts being executed. So regardless of what content the page has. So it can also create some errors, but there are different cases when this type of scripts can be used. So for example, if we put some advertisement or something like that on the page, that some things that don't depend on the content of the page, then probably we can use this async attribute. So here we can see how the time frame of how these attributes work. So for example, if we use just the script tag, our HTML page is parsed, then it stops parsing, then our script is loaded, and then it is executed. And then if anything else is placed below the script on the page, then it continues parsing. Async works like this. So it downloads independently from the HTML, and then it's being executed, and then the HTML code continues parsing. And defer, it works like this. So it is downloaded, and it waits until the HTML page is loaded, and only then it starts executing. Okay, so do you have any questions here? Okay, I hope everything's clear by now. And let's move on. Today we have a lot of new information. Okay, so this is how the scripts can be linked to the page. Then we can also say a few words about the use strict directive. Sometimes you can see these words in the header of the JavaScript document. What do they mean? Just a second, I will open. What do they mean? The strict mode, it was it didn't exist in standards older than ES5. So it was created to avoid errors. So for example, in older standards, you could mistype a variable or do any other create any other error that wouldn't be seen. You wouldn't see it, or you couldn't track it. And if you write these two words, then such errors are tracked, and you can see that an error is thrown. So for example, if you mistype a variable, your browser, your environment, that's where your JavaScript code is executed, it will throw you an error and show you that you have done something wrong. So if you write the ES5 code, then you should always put these two words on the first line of your JavaScript file. There also are a list of keywords or reserved words. So for example, if you create a function or a variable or something like that, any other, I don't know, any other thing, such, for example, object or array, and you need to give this instance any name. These words cannot be used for names. For example, you cannot create a variable with the name of await or name of break, because these words, they are reserved for something else. You should also define the difference between expressions and statements. If we come back to different approaches, as I told you, there is declarative approach and imperative approach. So an expression, it is an example of a declarative approach. So for example, if a function returns us a value, or if there is a variable, so it is something that can be used as a value, here we can see an expression. So for example, an expression of true or an expression of this mathematical operation. So for example, 2 minus 1 equals 1, and it is a value or an expression. And statement is a bunch of code that should be executed. So for example, if we say to our program that it should welcome message or warning, these are bad names for functions. Usually a function is named with a verb. So a better name here would be show welcome message. So this is what we tell the program to do. And it has, in most cases, it has a side effect. So it is not a value that is used. Instead, it is a command that we are telling our program to do. And we will later talk about variables. So a variable is a named container for a value, and the name that refers to a variable is called an identifier. So let me show you a simple example. Let me clear this. For example, like this, variable a equals 3. So 3 here is a value, and a is a name or an identifier of this value. Sorry, for this variable. Variable names can start with the letter underscore or $sign, and we can also use digits for the variable names, but a variable cannot start with a digit. And in JavaScript, we mostly use this camel case when we start the variable name with a lowercase letter, and then each new word we write with an uppercase. So for example, I go here, for example, my new variable. So it's written like this. And I can write an underscore here, but I cannot write digits here. So as you see, it's not highlighted anymore as a variable. But for example, here I can put digits and it will work fine. When we work with variables, there are different stages of, I would say, of a variable's life cycle. So first we declare it. Here you can see this variable A syntax. It's just we claim that we want to create variable A. What value it will have, it doesn't matter right now. Then the initialization. So here we reserve memory for this variable, and assignment. Here we um, give this variable a value. So for example, here it goes through these stages and we reserve memory, and we we give this variable a value of 100. Then we later we use this variable and can either change its value, or we can use it in some operations. So for example, we can create another value like variable b, which will equal to a plus 30, and variable b will equal to 130. So another variable can use this variable in its calculation. There are in JavaScript currently, in new syntax, there are currently 3 types of variable declaration. In ES5, there was just var type, but with ES6, we have this let and const syntax as well. They have different behavior, and let's take a look at what this difference is. So variables declared with var are available in the scope of the function they were created, and if there is no function, they are available globally. So what this means? Here you can see how they can be created. So we can first declare the variable and then give it a value, or we can both create and assign a value at the same time. If we work with functions and we create variables inside the functions, these variables cannot be accessed outside the function. So for example, here we use a function, and inside there is a variable of hello, and under the function we're trying to log this value, and it doesn't see this variable, so as if it doesn't exist. So this variable cannot be accessed. For let variable, the scope is even more limited. So the syntax for creating is pretty much the same. So we can declare and assign a value at the same time, or we can assign value later. And the scope of the let variable is a block of code, not a function. So this is what a block of code is. Anything that exists inside of curly braces. So it can be either a loop or an if statement. And for example, here inside of the if statement, we declare a variable hello and try to access it outside and get a reference error. So this is what the main difference is. Const variable works pretty much like let, with the only difference that it cannot be changed. So we just can't do anything like this. So we cannot write const x and assign a value later. We should write with this syntax: const y equals hello world, and it cannot be changed like never ever again. However, if we work with objects and with different properties of an object, so for example, here we have an object with a property of a which equals to 1. We can add new properties to this object, or we can change, for example, object a, we can set it to be equal to 2 or 3 or whatever else, and it will work because objects are a little bit different. We can, when we work with older syntax, we can accidentally create global variables, which is kind of a bad practice. To avoid doing this, we have to use the strict mode. As I said, as I showed you on previous slides. And there is also such thing as hoisting or temporal dead zone. What it is exactly. So for example, here we have a variable, my new variable. Let's delete 1, 2, 3. And if we try to log this my new variable before it was assigned a value, it equals to undefined. And if we try to access it after, here is how JavaScript code is executed. So we first, under the hood, it works like this. So this variable, this name, when it is defined, declared, it is moved implicitly to the first line, to the beginning of the document. You cannot see it, but it is what the JavaScript engine does under the hood. So this variable, my new variable. So it already knows that this variable exists. It only doesn't have any value. for now. And if we try to log this value, which we don't have, but we know that this variable exists, we can see the undefined. So this is the word that shows us that we don't know the value or it doesn't exist. Then we see that this we assign this value, it equals to 3, and then if we log this again, we see the value of 3. However, if we change the this word from var to let and try to execute our code again, we see that this line it doesn't exist in this case, and this line it is in a temporal, so-called temporal dead zone. So this variable, it doesn't exist here. But if we delete this line or command it, we can see that without this line, this code works fine. So this is another difference between the older syntax and the newer one. So between var and let. And this is also what you should know about them. So as I said, if there is no value assigned for this variable, it has the value of undefined. So this is a special data type. For example, here, if you declared a variable and it doesn't have any value, its value equals to undefined. But for example, here, if you try to assign to the variable z the value of the variable foo, but you see that the variable foo doesn't exist here, you get a reference error. So these values are, these cases are different because this one has the value of undefined and this one just doesn't exist. Here we can see different examples of how this is used. Probably you can execute this by yourself in your code pen or in any other environment. So probably you will look at, you can look at different examples of what they will equal to after the code execution and test yourself. And another example of the variable scope, as I told you, for example, this var variable, it's with the help of hoisting process. If this code executes, it will go to the beginning of the document. So it goes here. It passes these curly braces. And if we try to log it outside the if statement, it will work fine and it will log the value of 5. And for the let variable, this variable stays within the curly braces, the block of code. And if we try to log it, we get a reference error. Another example of hoisting. So here we declare a variable x which equals to 3, and before we assign this value, we try to log it. More precisely, if we try to log if it equals to undefined, which it does, because here at this line, it still doesn't have a value of 3. So we see that this statement within these brackets, it is true. And yeah, as I said, variable declarations are hoisted and values are not. So variable x is what is hoisted to the top, and the value of 3 stays. It only appears here, so it's not hoisted. The question what to use, var, let, or const, is the answer is pretty simple. If you work on a legacy project with old syntax, you will probably use var variables. And if you work on a modern project with modern syntax, then you will use let or const syntax, and the var syntax will be forbidden. Okay, before we switch to functions, do you have any questions? I see something in the chat. This is basic. Okay, that's great that this is basic for you. Probably somebody else has questions. Usually prefer let or declaration. Yeah, if you work with the modern syntax, then it's totally fine to do that. Okay. If everything's clear by now, maybe we could take a little break, if you don't mind. It's been already an hour. Okay, so if nobody has any objections, then it's 7:33 now. Maybe I will meet you at 7:40, if that's okay for you. 7:40. Okay, so see you in 7 minutes. Hello again. I hope everybody's back. So let me share my screen once again. And we will proceed with talking about functions. So for functions, in general, there are two types of how we can create a function in JavaScript, and these are function expression and function declaration. How can they be written? It goes like this. We can either create a function, let me write it like this, function declaration, and we write it like this, the keyword function, for example, my func, with brackets like this, and inside we write what we want this function to do. So for example, you can console log 1, 2, 3 or something like this. Or we can create a function expression. Another func, for example. And we log 4, 5, 6. This is how they are. Sorry. The difference is that we declare a variable. Is another func and console log. So the difference in syntax is that the following. So here we declared our functions, and here we can execute them. For example, we execute my func and clear, and sorry, just a moment. Please. What could go wrong here? Does anybody have any thoughts? Because everything looks just fine. Let me save this. Line 9, it shows me an error at line 9. Sorry. Yeah. Yeah, so here, if we, yeah, here's how this syntax looks like. Or we can use it, for example, like this. Give it a name. So in this case, it would be anonymous. Yeah. So here we create a function with the name of myfunc, and here we execute it. So we just tell what we should do when we give the command for this function to be executed, and here we do this. And we can call the function func, or it's a name of another func. And execute it here. And if we clear the console, we see that both expressions have been logged. Where that difference goes, if we delete or comment this execution here and try to execute these functions before they were declared. If we do it like this, we see that this function declaration has been executed fine. So we see the value of 1, 2, 3. So this one goes okay. And if we try to execute another func here, we see that it is not a function. So how this works? This function declaration is hoisted to the top of the document, and when our code is executed, it sees that this function is a function and it can be called. However, this one, it exists as a variable, and a variable here has a value of undefined, and if we try to call it, it tells us that it is not a function. So this is why this type of syntax has some bad side effects. So it's more preferable that you use function declaration because it is hoisted. The immediately invoked function expressions also exist in JavaScript, and this is how they work. So we can delete all this stuff here, and we can write example function. Thing goes inside the brackets. For example, console log 1, 2, 3, and we call it immediately. So this function is created and called at the same time. They have some cases that they are used in, for example, some library code, and in older syntax in ES5, we didn't have modules, so IIFE is what we used to as a polyfill to modules. So here is like some cases of usage. However, in the ES syntax and the newer ones, we don't use them as often as we used to. We can also write them a little bit differently. So for example, this is an example of syntax. We can also use this one. Can put an exclamation mark here and try to run this code, and it will work exactly the same as this. and we can also place our brackets differently, not here, but put all the expression in brackets, and it will work exactly in the same way. Yep. Yeah, parenthesis here, doesn't matter. Okay, before we switch to data types, do you have any questions on functional expression? Yeah, thank you. Do you have any questions on the functions? Okay, if everything's clear, let's talk about the data types. Let me make a bigger presentation. Yeah. In JavaScript, there are 8 types of data. 7 of them are primitives, and object type is different from them. In ES5 standard, there were only 5 of them. Not sure about 5, maybe 6 with objects. But in ES6, newer types were created, such as symbols and big integers. Just to be clear, functions are not a separate JavaScript type. So functions are objects. So they can be placed here. If we want to know which type our variable has, we use the type of operator. So for example, if we switch to JSBin again, and we want to show the type of example 1, 2, 3, we see that this type is number. Or if we put quotes here, we see that it has become a string. So this is what can show us the type of any variable. Primitive values are the following. They can take different values. Symbols and big integers will be discussed in the upcoming lectures. So today we will talk mostly about null and defined Boolean type, string type, and number type. So yeah, let's move on to these types. Numbers are represented as a 64-bit floating point number. So what this means, it can be either an integer or any number with a floating point, or it can be defined as a hex or any other format. Infinity is also a number, both infinity and minus infinity. And there is a small, I would say, bug in the language. If we try to add different numbers. So for example, here we can add, just let me show you. 0.1 plus 0.2 equals 0.3. And if we run this code, we see that this expression equals to false. So it is not true that these two values are equal to each other, and it can be considered as a bug. So just for you to beware of that. It happens because of the floating points. Not a number is a special case of number. Maybe it would sound weird because how can not a number be a number? So this is a special value that we can get if we try to execute mathematical operations where they cannot be executed. For example, if we switch to JSBin, console log, if we try to, for example, we have a string and we want to divide it to 2. Yeah, so we cannot perform math operation with a string. So that's why we get this not a number type. Here we can see other examples where we can get it. So for example, if we want to divide something by 0, and infinity by infinity, or any others, any other operations. We also have this is nan method that we can check if any value equals to not a number or not. So for example, we can write it like this, not a number. This is here. So this equals to not a number. So if we check it with is not a number, we get a value of true. Okay, let's move on. Here we can see ways of how we can convert our values to numbers. So for example, if we have a string, we can use either parseInt or parseFloat or number methods that we that can help us. For example, we can have a constant of a variable. I don't know. For example, string of 1, 2, 3 string, and we want to make a number out of it. So here is what we get. We get not a number. If it just can't create a number, but if we remove all the letters from here and leave just numbers, we see that this string can easily be converted into a number. Parsefloat and parseInt work just the same. For example, if we use the two, parseInt is where we put the dimension. So here we use the 10 system when this number is calculated, or parse float. It's pretty much the same. For parse float, doesn't have the second argument, just the value, and for the parseInt, it just the string and the radix. Okay, so for strings, so strings is everything that goes between the quotation marks, that can be defined just as a text, plain text. And we can also convert numbers and all other types to strings. So here is what we get if we try to convert different values. For example, this syntax won't work because this one is not a variable. This one will work, but it's not recommended to use this syntax. This one will also give us some kind of side effect, but this one is totally fine. So we can either address the number in parentheses, or we can assign it to a variable and call the toString method on a variable. Booleans, undefined and null, are also separate types, data types in JavaScript. So Boolean can take only two values of true or false. Undefined is something that we use when a variable doesn't have a value, when it is supposed to have one, but it doesn't have. And null is something that represents the absence of any value. So here it has a value of null or nothing, and here it should have a value, but it is not defined. An object is a complex data type, so it's not a primitive, and its behavior is quite different. So if we want to compare, for example, different objects, let me show you an example. So object is a structure that is put inside curly braces, and it can have different properties or methods inside. So for example, it has okay, so let it be, for example, a person. name with name of John. Let it be a string. Age of 20. So this is how an object looks like. So it is like a combination of different properties, and these properties can be either other objects or they can be primitives. We can also define different methods inside. So for example, we can define a method called greet. Mm. Hi. And we can execute this as, for example, console log person name. And we can call person's method greet. Sorry. Let it be like this. Yeah, so greet is a method here, and name is a primitive. So this is how objects look like. And if we create two different objects, so for example, let it be person 1 with the name of John, and person 2 with the name of John. And if we want to check if these objects are equal to each other, person 1 equals person 2, we see that these are two different objects. So they are referenced by a special link. So it's not like a primitive value. It's not like primitives which are compared by a value. However, if we try to compare these persons' names, the name of person 1, if it equals the name of person 2, we see that these values are equal, and this comparison equals to true. So this is how objects behave when they are compared. Just a moment. Oh, yeah. So we have already talked a little bit about type conversion. There are two types of type conversion. It can be either explicit or implicit. So explicit is something that we do intentionally, like for example here when we create like number of 1, 2, 3. So we make an explicit or a direct conversion. We want we tell our JavaScript engine to convert the string of 123 to a number of 123. And we can execute anything with these numbers. So we see that they are added to each other, and this operation can be executed because we have told our engine to convert this data type. However, we can leave it just like this. And we see that we didn't tell our engine to convert anything of these types. So it has performed its operation how it thinks it should have been done. So here we get this side effect of joining these two strings. So we wanted, maybe we wanted the string to be converted into number, but instead we got our number that was converted into string. And this is why we should avoid implicit data conversion. Just a second. So if we want to convert anything to Boolean, here is here are the types that we want to convert, and here is the result. So for example, if we want to convert undefined or null to Boolean, we get a result of false. For Boolean, there will be no conversion because it already is a Boolean. For numbers, we get false for zeros or not a number. Otherwise, it will be true. For strings, the result will be false for empty string. So just one quotation mark and another quotation mark. If the length is equal to 0, and objects, arrays, functions are always true. So here are some examples that we can check. You can do it by yourselves in JSBean or CodePen or any other environment. If we want to convert our types to number, if we have initially an undefined or a null, it will be converted like this. So it will be either not a number or 0 plus 0. For Boolean, the result will be 1 for true or 0 for false. For number, there will be no conversion. And for strings, there it will be parsed. So you can get either a number. So for example, like here, 1, 2, 3 can be converted to number, but 1, 2, 3 string. Just show you. So as I said, it will be converted into not a number. And for objects, we can define a value of method so that it will show us a number. So for example, let's create an object. Okay, let it be the same person. Name of John. Person to number. Sorry, it's to string number out of person. We get not a number. However, if we create a method of value of, example, we return 20, which is his age. And if we convert this object to number, we get the value which is returned inside of this method. So here you can see some other examples which you can check by yourselves as well. If we convert our data types to strings for undefined and null, these will be the strings undefined and string undefined and string null. Same for Boolean. For number, it will also create a string with the value of this number. For string, there will be no conversion. And for an object, there goes exactly the same for as for numbers. So for example, here we have our value of method. Let's just so by default, if we try to convert this create string out of object, we get this object string, or we can string John. So here we can redefine the toString method, which will convert our object to a string. Here you can see some other examples. And here you can also see different expressions of what some values are equal to or not equal to. So these are also very useful to check. Okay, before we move to operators, do you have any questions on the data types? So the questions in the interview show the results by console log. Yeah, so here you need to check how the data conversion goes. So whether it will be a string or a number or anything like that. Yeah, so also one or two can be either strings or numbers. So you have to check this in the console to see how it will work.
And can you show that code right now.
Yeah, I
Code
see.
right now.
We can check it.
Yeah, check right now. Yeah.
Okay, so
Console log. Yeah.
like this.
Yeah.
I guess probably it should be something like this because
One
ABC.
ABC3. Yeah, I think result is one ABC3. That is yeah.
Yeah, so this one will be one ABC2 because the string is
three.
in the middle.
And number two and question number two is three ABC. Yeah.
Yeah,
I think that.
so I guess here I guess we will get 3 ABC and here ABC 1 2 as a string. So it will be like this. Checks 3 ABC, I guess it will be. Yeah, 3 ABC because we get our numbers first and then we concatenate it with a string. And here the string goes first. That's why everything, the result will be a string. So it will be ABC 1 2. Yeah. Yeah, so this is very useful to check before you pass any interview because these questions are very common. So you can easily face them at the interview. Okay. Okay, so let's move on to the operators. Just a moment. So operators are, if we try to define what it is, these are some commands that we perform with our values or with numbers, with strings, etc. So they can be either arithmetic or assignment, logical, comparison, and others. So let's see what the examples are. For arithmetic operators, these are our basic math operators like addition, subtraction, multiplication, division, or modulus, and increment or decrement. Examples we can see here. So if we console log the result of this operation, we can see this number, or if we see this increment, it will take this value and add 1 here, so it will be 21. Same with decrement. So this operation will be performed. It will show 21, and on the next iteration, it will show 20 for this value. Here we can see the variable x, which equals to 25, and it is added 20. So here is what this type of operation is. So this syntax means x equals x plus 20. So here we can log it and see that it equals to 45. Here you can also see some different mathematical operations, like if we divide anything by 0, it can be an infinity, or for 0, it is not a number. And the weird thing, in both infinity and not a number are numbers. Assignment operators you can see here. So here we can assign a variable. These examples I already showed you on the previous slide. So x plus equals y is same as this syntax, and the same works for other operations. Comparisons work like this. So this type of comparison, it doesn't it's how to say, it implicitly converts data types and try to compare values after conversion. So for example, if we try to compare the string 123 to number 123, here our JavaScript engine will convert the types and compare after that. So we can get the result as a true. However, if we put this ternary equal sign, we see that the result equals to false because the string 123 is not the same as the number 123. So this expression means is not equal to, and this one works the same as this one, but the opposite. So it's not equal to, it's not identical. Greater than or equal to, and same for less. So here is how we can compare our values. Here you can see different examples. And another weird thing, that null does not equal to undefined. However, here you see that they are equal, because if we convert these data types implicitly, then we can see that they can be they can exist as the same data type. And it is not recommended this type using this type of comparison. So we mostly use the strict one. Logical operators are also widely used. So this one is the AND operator, which returns true if all the expressions are true. And this one is also called as OR operator, and it returns true if at least one of the expressions equals to true. This one converts the expression into a Boolean and returns the opposite Boolean value. So for example, we have a variable a which equals to 1, and we want to log not a. So we get a value of false. However, if we use a as a 0, we see that not a will be true. And for and an or comparison, we see that, for example, a equals true, b equals true, a and b will equal to true, a or b will equal to true because they are both equal to true. And here we see different combination of this, these statements. we can also use this null coalescing operator, which is pretty much like or. However, it defines, it doesn't count zeros or empty strings as false. So it only counts null and undefined as false. So here we see some examples. For example, true and false will equal to false because not all of them are equal to true. So here we will get true because they are true-ish. And here, high, true, null, and 1 will equal to false because null is false. Not. So here we can also see different combinations. We can check some mixed types of data, which you can also check by yourselves. And here we can also see different examples of type conversion, which, as I have already told you, can be both implicit or explicit. So like direct or indirect. Here we can also see different examples of numerical conversion or conversion to numbers. Same here. Here we can see logical conversions or conversions to Boolean. Boolean from 1, Boolean from 0, which equals to false. Or sometimes we use this type of conversion if we want to convert our value to Boolean. So we create an opposite Boolean value and we create the opposite to the opposite. So this not 5 equals to true. Sometimes we use this syntax as well. And after speaking about conversion and especially about Booleans, we can also talk a little bit about our conditional executions. Probably you have met these if-else statements, which mean that we execute some code under a certain condition. And if this condition equals to false, then we execute some other code. So here we can see some examples. So if inside we write a condition and execute something, or we can, there is an optional syntax of else, and if this condition is not met, then we execute this statement. So for example, if these two values equal to each other, we execute this bunch of code. Instead, if these are not equal, then we execute this. The result will be like this. So inside the if parenthesis, the expressions are converted into a Boolean value, so either false or true. And if you don't make this explicitly, it will be made under the hood of the JavaScript engine. Here you can see a bad practice. So try not to write your if-else statements like this. Though it will work without the curly braces, it's recommended that you use them always like this. Sometimes it's better to use the shorthand syntax. So for example, here you have a constant of I, constant of j, and the result. So here, if I doesn't equal to j, the result is true. Otherwise, the result is false. However, you can write it as this. So result is I equals to j. So it will always be either true or false, depending on what the result of this expression is. So this syntax is shorter and is more recommended to use. You can also use a chain of if statements with else if. So here, for example, we have a variable, a city variable that can be either Szeged or Debrecen or Budapest, and depending on what its variable equals to, we execute different chunks of code. So here we can use this. So if city is this, then we console log this. Else, if this is it takes other value, then we log this value. Or in the end, if it doesn't equal to any of these values, we log this unknown city. So this is the default case. We can also use the ternary operator to shorten this syntax more. For example, here we have this salary of 90,000 and the reaction. So if the salary is more than 50,000, the reaction is not bad. Otherwise, the reaction is not enough. And here is how we can shorten this. So we can define a variable of reaction, which will equal if the salary is more than 50, then with this question mark, we check the if statement, and if it is true, it is equal to not bad. Otherwise, it is equal to not enough. So this is the shorthand syntax for this. And for the example of the previous slide, if we have a lot of if cases, so for example, we can we have a variable of city, which value we check each time. We can write it like this, so we can write like a switch syntax with different cases. So for each case, we console log each value. And if it doesn't equal to any of this, we write a default case where we log unknown city. So the default case is not a mandatory part. So, but it is a good practice to write it, and it is mandatory in production code, not by the JavaScript syntax, but by the team, by any team that uses JavaScript. So Yeah, what else? Sometimes we can use this type of syntax. So we can check if these values are true and return some value for our function. So here you can check some other examples of conditional statements. And if you have a question, what happens if we don't write a default case? It's just the answer is that it can produce bad side effects on your code. And sometimes if the default case for the switch statement just doesn't exist, then probably it's better to write it not as a switch statement, but as an if statement instead. So here, sometimes it is also recommended to use not the switch statement, but the dictionary object. So here we create a so-called dictionary object. And instead of logging a specific value for a specific city, we address a property of an object. So this syntax is much shorter and easier than this. And if we compare two paradigms or two approaches, this one can be more of a functional one or imperative. Instead, this one goes more with the object-oriented programming. And probably this one is more recommended for usage. Okay, so our last topic is loops. And before we switch to that, do you have any questions? Because we have already out of time. Have already run out of time. Okay, so the last topic for today is loops. Sometimes we want to iterate through an array of numbers and do something with these values. So for this, we need a for loop, which works like this. We declare a variable inside of this parenthesis, and for each value of this variable, we do something with this value and go further. And at each step or each iteration, we change this variable. So for example, here for let variable I, which starts with 0 and until it it becomes equal to 5, we log it and add 1 at each step. So each iteration will be like this: 0, then +1, then 1, +1, 2, 3, 4, and then it becomes equal to 5, which doesn't fit this condition, and so we exit this for loop. We can also skip different parts in this syntax, and this syntax is also not recommended for usage because it can have different side effects. Another type of loops is called while or do while, and it works pretty much the same, but we write only our condition and what we do with a variable. So here we declare a variable which equals to 0, and while it is less than 3, we add 1 to this variable. So finally, it will equal to 2. And in this example, for do while, we declare a variable of result and I, which equals to 0. And while I is less than 5, we do something with the I variable. And we log the result, which is a concatenation of these variable strings. We can also iterate through different properties of an object. So here we log each property, const property in object. So here it will be A, B, C. So the prop will be the key and the object prop will be the value. So here is how we log it. And for the for of syntax is used for arrays. So here we iterate through an array, and for each element of an array, we log it, but before that we increase it by 1. So here it will be like 11, 21, and 31. We also use such words as break and continue, and they mean that at a certain iteration we can skip this iteration, or for the break we just exit the whole loop. So this is the difference of how we do this. So here we exit out of this iteration and skip to the next one, and here we exit the whole statement. So this is all for today. As I said, there was lots of information. And do you have any questions on this topic? Okay, then probably if you don't have any questions, then the next class that I will, yeah, so basic. I'm so glad that you already know all this stuff. So yeah, the next time we will meet will be next Wednesday, and this week Katerina will give lectures to you. So I will wish you again good luck with your homework, and I will see you next time.
Yeah, thank you.
Yeah, thank you for coming today. Bye bye.
Bye bye.